Happy Friday, everybody. This is the review of the homework for today, which is dividing radicals and rationalizing the denominator. Just wanted to let you know that we will have our final test on simplifying radicals, adding, subtracting, multiplying, and dividing on Monday. Tuesday is a catch-up day. Wednesday, I believe there's a school-wide activity to do, and Thursday, I will have something posted for us to meet if you would like to say our goodbyes. So anyway, I've worked it all out. I just found this is easier. And our first problem is you were supposed to only do the evens. The square root of 6 divided by square root of 50. So what I did first is I broke down the square root of 50 to see what I could pull out. 25 times 2, and 25 being the perfect square number, I get a 5 times square root of 2. And the square root of 6 is on top. So this is what it simplified to. Then we do not, as mathematicians, prefer to have radicals in the denominator. So I multiplied by a form of 1. Square root of 2 over square root of 2 is a form of 1. So I haven't changed this value. I'm just making it easier to look at. It's like changing clothes. Same person underneath, different outfit on the outside. So 5 square root of 2 times square root of 2 makes 5 times 2 on the bottom. I'm going to take the 6 and the 2 and multiply it on the top. So root 12 over 10. And then I can take the root of 12 and make it the square root of 4 times the square root of 3. And that's where this 2 came from. And then anything that's outside, it's just like a fraction, 2/10, I can simplify that part. And there's nothing to simplify further with the square root of 3. So root 3 over 5 is my simplified answer. And I have, in this process right here, rationalized the denominator. And that is our preferred way to write division of radicals. All right, number 4, 8 root 5 over 2 root 36. I like 36, perfect square number, so 2 times 6 on the bottom. 8 root 5 over 12, since both of these numbers on the outside, I can treat it like 8/12 and simplify. I divided both of them by 4. I get 2 root 5 over 3 as a final answer for number 4. Number 6, I try to do a little bit of work beforehand. There's lots of ways to do this. You just have to make sure you don't break any math rules. So 8 and 12 are both divisible by 4, so I got a 2/3. Then I proceeded to multiply by the root. I could have simplified root 18 and just root 9 times root 3 and done that as well. But I did a little different here. I get 2 root 252, 14 times 18, can multiply things under the radical. And an 18 comes out of this, because if you multiply a root by that same exact root, that radicand is removed. 3 times 18 makes 54. I took 252 and 36 and 7 go into it. Luckily, 36 gives me a 6 when I take the square root. So 2 times 6 over 54, and you could simplify it then. Or I said, hey, 6 goes into 54. So I just did some simplifying right away. You get 2 root 7 over 9. All right, number 8. Again, I simplified the quote-unquote coefficients, the items outside the radicals. And I end up with 8 root 56 over root 2. Now I looked and I see that 56 and 2 are both under the radical, so I actually can simplify. I can take 56 divided by 2 because they're both inside the radical. I can do that. And I get 8 root 28. Nothing's left on the bottom, no more fractions. And then you just go through the process of simplifying. 4 times 7 makes 28. 4 is a perfect square number. Take the square root, you get 8 times 2, or 16 root 7. Number 10. Again, 2 and 6, I can simplify. They're both outside the radical. And then I looked at 15 and 12. This is the same as saying, like, here, let me... I wonder if I can just draw this real quick. This is the same as saying, hey, I'm going to take and make a big square root or radical, and I'm going to say a fraction exists under it. And I can do it because they're both square roots, not one being a squared root, one being a cubed root. And if you have a fraction underneath the radical, again, you can simplify it. So 15 divided by 12, or no, 15 and 12 both are divisible by 3. I love the square root of 4 because 2 comes out and 3 times the 2 makes 6. So root 5 over 6 is your final answer. Number 12, again, I did some simplification both outside and inside of the radicals just to make my numbers easier to work with. Multiplying by root 9 on both top and bottom to rationalize the denominator. And I get 7 over 18, 2 times the 9 here. And 45 comes from root 5 times root 9. And again, I'm going to pull out what I can in perfect square factors. 9 times 5 makes the 45. 7 times 3 is 21. So I have 21 root 5 over 18, and 21 and 18 are both divisible by 3. Final answer is 7 root 5 divided by 6. Just remember, you know you are done simplifying when you have simplified the numbers outside the radical as much as you can, and the radicand inside the radical cannot be factored into a perfect square number and another factor. Number 14, we're just going to rationalize right away. So I get 27 times 2, root 54 over 2 is my answer. Again, we can pull things apart. Root 9 is 3, and I get 3 root 6 over 2. And that is rationalized, no square root in the denominator. Next one, again, I'm going to rationalize the denominator. I get root 40 over 8. Square root of 4 pulls out a 2, so I have 2 root 10 over 8. Simplify, and I get root 10 over 4. 2 goes into 2 once. You could put a 1 here if you want to, but not necessary. And 2 goes into 8 4 times. All right, 18. Again, I am simplifying. I suppose you could have said 20 over 28 and simplified it that way, but divided them both by 2. But this works as well. And I get root 4, so I kind of could cross those out. Anything that's the same on the top and the bottom of your denominator crosses out and makes a form of 1. So I'm left with root 5 over root 7. I rationalize by multiplying by root 7 on both the top and the bottom. That makes a root 35 on the top and a plain old 7 on the bottom. Number 20, again, I'm rationalizing the denominator. I did see square root of 4 makes a 2, so I pulled that out. So I get 2 times 2 root 6 and a 5 times 6 on the bottom, which is 4 root 6 over 30. Nothing I can do under the radical, but I can divide both these numbers that are outside of the radicals by 2, and I get 2 root 6 over 15 is my final answer. 22, again, rationalize the denominator. I get root 2 over 4 times 2. Remember, square root of 2 times square root of 2 makes square root of 4, which pulls out a 2. And that is root 2 over 8. And I'm going to stop yapping and let you guys see this. I think I've talked about enough examples. But the final answer for 21 is root 21 over 6. And that is all. So I hope this went well. Make sure you do these problems and make sure you know how to do them. Remember, we have a test on Monday on Schoology, and it will be simplifying radicals and working with adding, subtracting, multiplying, and dividing. All right, thanks.